Hi students, I'm excited to share another awesome patcher lesson with you, and in this one we're going to learn how to solder. So soldering is the process of joining two or more metal surfaces together using a filler metal, and we call that filler metal solder. And we use soldering to create a lot of different things, but most commonly to create connections between electronic circuits or electronic devices. And pretty much everything you own has a printed circuit board in it, and these printed circuit boards can have tens, hundreds, or even thousands of tiny little soldering connections. So soldering is a really important skill for us to learn if we want to create our own custom electronics, and that's exactly what I'm going to show you how to do in this lesson. Let's get started. So the first thing that we need to identify are the resources needed in order to solder safely. So that's creating a safe workspace to solder in. You should solder in a clean area with plenty of space to work, and you also want to ensure that the table you're working on is protected, as hot liquid solder might drop onto it. We also need proper ventilation, which can be achieved using a fume extractor. Smoke is a byproduct of soldering, as we are melting the solder to create our connections. And while we strongly suggest that you use lead-free solder, this still isn't something that you want to be breathing in. You also need your soldering iron, of course, as well as something to clean it with, like a brass sponge, though you could also use a damp kitchen sponge as well. We might need some other tools to aid in creating our circuits, including scissors, wire cutters, and blue painter's tape. And while I won't be using them in this lesson, some may prefer to use helping hands or some type of jig to hold your circuit and components in place while you solder. Lastly, we need safety glasses to protect our eyes from potential hazards while we work. Now, to learn the basics of soldering, I'm going to be constructing a printed circuit board using paper. You can download this template for free, as well as check out the assembly guide and other resources and instructional materials for learning how to create your own custom electronic circuits at patcher.io. We also need our components, or the parts of the circuit that's actually going to allow this to function. So we're going to be using copper tape to actually create the conductor that our electricity can flow through. The paper is going to act as our insulator. So after we put tape on this piece of paper, the electricity will only flow where we lay the copper tape down. We're also going to need our battery and our battery retainer. That's actually going to provide power to our circuit. And we need our LED to light up and our resistor to actually ensure that we have the right amount of current flow for our circuit to function. I'll get into much greater detail about all these components as we start to solder them together on our circuits. So the first thing we need to do is to cut the paper boards apart so we can work with them just one at a time. Next, we'll lay down the copper tape to create the paths for our circuit board. We want the tape to overlap at each corner, so I like to cut the tape into small pieces and then lay them down one path at a time. In tight spaces like around the battery, it's important that the positive and negative paths do not overlap each other, or else we might create a short circuit, one that completes the electrical connection without going all the way around the entire circuit board first. A pro tip for tracing the circuit with copper tape is to carefully use a hobby knife to trim the overlapping edges for a nice clean circuit design. While we've successfully routed our pieces of copper tape so that they are overlapping, we want to ensure that there are good electrical connections between them. To do this, we're going to solder each tape connection. Remember, safety first. Put on your safety glasses and use caution, as our soldering iron is hot. There are a lot of different style soldering irons out there, but for all of them, you want to hold it in your dominant hand, and you want to hold it underneath the handle grip while avoiding the hot end that we use to create our soldering connections. We need to ensure that the tip of our soldering iron is always cleaned or tinned. So I'll be dipping and spinning it into my cleaning sponge before and after I solder a connection. To solder, I hold the iron in my dominant hand and the stick of solder in my other hand so it extends a few inches out to avoid getting burnt. I first need to heat the area that I want to solder, as the solder will flow towards the heat. So I gently press the tip of the soldering iron onto the copper tape joint, and after a few seconds I add the solder. I then remove the solder first, followed by the soldering iron, in order to allow the solder to flow. Nice job! Notice how the solder flowed over the whole corner. This is because the corner was hot first. A common mistake is when we go in with the solder first, or even at the same time. If the connection area isn't hot enough, the solder will just flow right to our soldering iron rather than the circuit board. Another common mistake is removing the solder iron before the solder rather than at the same time. This isn't too much of a problem, just carefully reheat the solder stick to release it from the board. So now I'm going to just finish soldering all of my tape connections while also cleaning up my soldering iron every few connections in order to ensure it is tinned and to ensure that I don't have too big of a buildup from extra solder. And while there isn't a tape connection here, we want to put down a large pad of solder right on the negative connection for our battery. This will ensure that the battery, which we'll be adding later, has good contact with the copper tape. Be careful, while this is just a paper circuit board, all of our solder connections will be hot for a minute or two after we solder them together. So I think we're starting to get the hang of this, which is good because it's time to add our components. The first component is going to be the battery retainer. The retainer has two positive connections on the surface of it, and the bottom of the battery will be connected to the negative path we just soldered. Batteries are polar, meaning that they have a positive and a negative connection point. If we do not connect our polar components correctly, the electricity will not be able to flow through them. Before we attach the retainer, let's bend the feet or contact points of the positive connection downward just a bit. I find that this helps make a better connection between our battery and the flexible paper PCB board after we have it all assembled together. To make this a bit easier, we're going to rip a small piece of tape to secure our battery retainer in place before soldering. Once secured, I'm going to solder the two positive connections by first heating the connection for a few seconds using the soldering iron, then adding the solder to the heated area so it can flow between the tape and the retainer pad. Be careful, the battery retainer is going to be hot after soldering it, so let it cool for a few minutes before removing the tape. Next, we need to connect the LED. Like our battery, LEDs are polar and have a positive and negative connection. We often refer to the positive connection of an LED as the anode, which is the longer leg, and the negative as the cathode, which is the shorter leg. If you're working with a bigger, clear LED like this, you can also see the anode and cathode plates within the dome of the LED, and you can also see that the cathode plate is a bit bigger regardless of the color your LED emits. I'm going to bend the legs of the LED outward just so it aligns with the copper path on my circuit board a bit better. I'm then going to use a piece of tape to secure the LED place while I solder it. Like before, I start by heating the area by making contact with both the leg of the LED and the copper tape simultaneously, and then I add the solder to the area that's heated after just a few seconds in order for the solder to flow between the connections. After repeating this process for the other leg, it is secured. Remember, the component will be hot for a minute or two, so be cautious as you remove your tape. You can also carefully trim the legs of the LED to be a little bit shorter using wire cutters, but always remember to cut down and away from yourself or others to prevent any flying hazards. So now we need to connect the resistor. A resistor limits the flow of current in our circuit, and this is important as components, such as LEDs, often have a requirement for how much current they need. If you look closely, you can see color bands on the resistor. This identifies the value. For this circuit, I'm using a 22 ohm resistor or one that has bands that are red, red, and black. Like with my LED, I first bend the legs of the resistor so it aligns with the circuit and then tape it in place. Resistors are non-polar or without a positive and negative leg, so it doesn't actually matter which direction we solder it onto our circuit board. I then solder each leg by first applying heat with the iron and then adding the solder to create the connection. Remember to handle it with care as we remove the tape and cut off any excess. Okay, nicely done. We've connected all of our circuit components together and we have a nice complete circuit. The last thing we need to look at is a switch, and in this lesson I'm challenging you to design your own switch. Here's what I mean. I can test the circuit just by inserting the battery and then creating a connection across the pass for the switch by using an extra piece of copper tape, which works. But this isn't really a switch, not yet. If I actually use the tape to bridge these connections, the circuit would be on all the time, which is cool, but still not a switch. So how can we make a switch, or one that can easily toggle our circuit on and off? Well, there isn't one right answer or one way to do this. We know that our switch needs to connect these two copper leads together and disconnect them whenever we want. We also know that we need to use a conductive material like metal to create the connections. From that point on, it's up to you to figure out how to do it. Perhaps you cut the paper and fold it with some additional paste to turn it into a switch, or even add some more paper or cardboard or tin foil to make a push button. Or maybe you can even grab some things you have laying around, like a paper clip, and turn that into a toggle switch. The possibilities are really endless as we start to create our own custom electronics. So what's next? So now that you know how to solder, we can create just about anything. In our next lesson, we're going to look at how the skills that we gained in this paper printed circuit board project can be used to actually solder together real-world printed circuit boards, as well as how we can design and fabricate our own custom electronics and printed circuit boards. Visit us at patcher.io to start creating your own custom electronics today.